Okay, welcome to preparing for quiz 5. Remembering what we've done, kind of being reflective on it, and preparing for our quiz or retaking that quiz. Our first question says, Stephanie invests her savings in a bank to earn compound interest. So I must have had some money and I put it into the bank for a compound interest, which is different from simple interest. Which of the following models can be used to study the growth of my money? Well, first of all, compound interest, the equation is the initial investment, which is A, in parentheses times the sum of 1 and the rate or ratio times to the t power, which is time. Well, we've learned that linear equations do not have exponents. So because this equation has an exponent, we know that it's not linear. Quadratic equations have exponents, but that exponent is set at a number 2. So if it doesn't have a number 2 as an exponent, it is not a quadratic. Now we have learned that an exponential equation has an exponent has an exponent with a variable. In this case, the exponent is t. So it looks to me like this is an exponential equation. And definitely a cubic equation has an exponent of 3. So we know it's not cubic. So this function, this equation is an exponential equation. Question 2. We're going to choose the equation that is not exponential. So if it's, again, we had an exponential equation looks like y equals a times b to the x power. The x here makes it exponential. So since we have the x, it is an exponential equation. However, this equation here has an exponent of x. So it is exponential. The question is asking something that is not exponential. This one has an exponent of x. So that is exponential. This one has an exponent of x, and that is exponential. The x here is a base. Therefore, and a set number of 2 is the exponent. So this is not an exponential equation. So the correct answer would be y equals x to the second power. That's a quadratic equation. The next question here says, which statement best describes the pattern of increase for each company? So we have a table here where the increase of each company is different. We're not comparing which one is better. We're just comparing which one is, in this case, they both have an increase of profit because this is going up and this one's increasing. So that's not the issue. We're trying to compare these two companies. Well, from here to here is a plus of 3. Because 3 plus 3 is 6. From 6 to 9 is a plus of 3. 6 plus 3 is 9. From 9 to 12 is a plus of 3. 9 plus 3 is 12. 12 plus 3 is 15. 12 plus 3 is 15. So because we have a common difference and not a common ratio, this is a linear increase. So now let's describe this increase. From 1.02 to 1.0404 is times 1.02. from here to here, 1.0404 to 1.0612 is a times of 1.02. From 1.0612 to 1.0824 is a times of 1.02. And from 1.0824 to 1.1041 is a times of 1.02. This growth happens to be exponential. So which one of these statements, so now that I'm armed with this information, which one of these statements is correct? Let's find out. The company's increase in profit. Well, we all know that because both of them have been increased. So I necessarily don't think that that's the best way to describe that. Company A shows an exponential increase of profits, and Company B shows a linear increase of profits. Well, that is true, so that sounds like it should be the best. But let me hang on and read the others. The company's decrease in profit. Well, that's just wrong. So we're going to mark that one out. Company A shows a linear increase of profits, and Company B shows an exponential increase. Well, again, that's just wrong. So we're going to cross that out. Well, we have two wrongs, a good answer, and the more exact or the less ambiguous answer. So we're going to go with a Company A shows an exponential increase, and it's more specific, of profits, and Company B shows a linear increase of profits, and that's more specific. So we're going to go with the more specific answer. That, to me, makes it best, especially in math. Okay. Which function describes the graph below? Well, let's take a look at these functions. This function here does not have a 1. Doesn't have a number in front of it. So we understand if you were rewriting this, it would be 1 times 3x plus 4. Why am I writing it like that? Because remember, for any exponential formula, it is y equals a times b to the x powered, where a is your y-intercept. If I was to rewrite this equation, it would be y equals 1 times 2 to the x power plus 3. If I was to rewrite this equation, it would be y equals 1 times 2 to the x power. To rewrite this equation, it would be y equals 1 times 3 to the x power. Now, if there's a 1 in front, that's your y-intercept. So our y-intercept is 1, 1, 1, and 1. Hey, this graph isn't at 1. It doesn't go through 1. So what's happening to the graph? Something must be acting on it in order for it to move from 1 to 4, 3 steps up. What's happening? Oh, wait. This plus 3 is shifting the graph up 3 steps. So the correct answer is y equals 2x plus 3 is the function that describes this graph. Awesome. My next question says, which equation generates the geometric sequence below? Hey, I've learned something about geometric sequences. Geometric sequences have a special formula. That formula says, if whatever the answer is, you take the first term times the common ratio, or whatever you're multiplying by, to the n minus 1, which means the number previous. So let's say that again. your first term times the common ratio to the previous term's number, amount, quantity. So let's find out. Let's see what our common ratio is. First of all, let's talk about the first term. I'm sorry. Our first term must be that, because that is our term number 1. Our common ratio is, well, 2 times 7 is 14. 14 times 7 is 98. 98 times 686 is, 98 times 7 is 686. So the common ratio is 7. It's increasing, so I knew I wasn't going to multiply by a fraction. So it's increasing by a number of 7. Now, what is this? What am I supposed to do with this n minus 1? It's simply a part of the equation. I can always write this h sub n as a y. Because it really means if I put in a number for n, y would be this. What's y? So which equation looks most like what we just, the equation we just written? Well, by process of elimination, we know it's not that because it doesn't have a minus 1. This one has a minus 1, but the common ratio is a 2. This one has a common ratio of 7 and the first term of 2, but all of that is being taken to the n minus 1. That's not right. Here's the correct answer. It is most closely looks like this answer. Great job. Suppose a cultural bacteria begins with 5,000 cells and dies by 30% each year. Write an equation that represents this situation. Well, that sounds like a compound decay or a compound depression. So, each year was my signal that it's going to be compounded annually. I know I started with 5,000 cells. I know the rate that it's dying is 30. I know I'm going to subtract because the word dies. There are 2 equations that represents this function. One is y equals a sub 1 times 1 plus r to the t. The other one is y equals a sub 1 to the 1 minus r to the t. Which one is what is going to reflect the dying of these bacteria cells? If you guess this equation, you would be correct. So the first term is 5,000 cells. 1 minus r, 1 minus 0.30, which is the rate, is 70. 0.70. And we don't know how much time into which we're referring. Which equation most looks like this one? If you guessed the first one, you would be correct. Great job. Write a rule that represents the following function. Well, why don't you try this and we will come back to it. Hey, you were a little tricky with this. Notice that my rate of change for 7 for the